I forgot to start recording. So -4, our f of 0, plus our f prime of 0 times x over 1 factorial equals -3. Plug in a half for x, gives us a half of f prime of 0 equals 1, multiply by the 2, and you get f prime of 0 equals 2. Everybody good there with A? That was worth 2 points. 1 point for using this polynomial, 1 point for showing that the value is true. Good? I mean, verifying as in, yeah, show some intermediate step there. I guess, like plugging in the 1/2, I think is what they want. 1 point. And if I look more closely at it, it looks like, yeah, this was 1 point right there. And then the other point was doing the rest of it to get it. That's what it looks like. It's, it's not. It's hard to say from the scoring guidelines exactly. Right, exactly. Right, part B, we know that f double prime of 0 is -2/3, f triple prime of 0 is +1/3, so write the third degree Taylor polynomial. That should be easy. We already had -4 plus 2x, right? And then what were those values? We had -2/3 x, and then we've also got a 2 factorial down here, and then we're going to have a +1/3. We're going to have an x squared, and we're going to have a that's a squared, and that's a cube. Sorry. And we're going to have a 3 factorial down there. Good? Oh, right. Oh, yeah. Kevin, you're supposed to be doing an English thing. Let me finish this problem, and then I'll figure out how you're supposed to do that. It shouldn't take that long, I think. Thanks for reminding me. Mr. Sui was just talking to me about the English thing a minute ago. And I was like, I only have one student that has to do it. It'll be easy. And then I forgot. So we got -4 plus 2x. If you simplify this down, you got -1/3 x squared. And then what does this one become? Plus x cubed over 18. And they gave you 3 points for that. Wow. Somehow they gave you 1 point for the first 2 terms, which they gave you right away in part A. That's nice. 1 point for this term and 1 point for this term. Pretty generous. As in you left it as 1/3 of x cubed over 3 factorial or something. That's fine. All right. Part C. H has first derivative given by h prime is f of 2x. We know that h of 0 is 7. Find the third degree Taylor polynomial for h about x equals 0. So what do we need to do first? Maybe best to figure out what h prime is. Yeah. So h prime, which is f of 2x, ought to be what? You guys have it in front of you. I don't have it in front of you. So -4 plus 4x, and then I don't remember what the other ones were. Was it a 1/3? Minus 4x squared over 3. What? Oh, what do we have? Yeah, 4x squared. And then the last one should be 8x cubed over 18, which should be what? 4x cubed over 9. And then what are we going to do with that? This was f of x, so we just plugged in 2x for each of the x's. Good? Or no? Not good? This is that. This is f of x. This is f of x. That is the first four terms of it. I mean, isn't that all it's asking us for? Find the third degree Taylor polynomial for h. So, how were you thinking about it? Oh, I see. Yeah, you could do that too. We can go through and do it that way in a second if we want. Well, this is just h prime. We need to find h. So what is h going to be? We just have to integrate it, right? So h should be the integral of this. We'll say from 0 to x of negative 4 plus 4t minus 4t squared over 3 plus 4t cubed over 9 dt, and so on. So what does that give us? It gives us negative 4x plus 4x squared over 2 minus 4x cubed over 9, and then plus 4x to the 4th over 4 times 9. And we know that h of 0 has to equal 7, right? So this is plus some constant. This is h is this, and so then when x is 0, our constant is 7, so we end up with h equals 7 minus 4x plus 2x squared minus 4/9 x cubed. Which is 0 equals 7, so constant is 7. Is that what you got? Yeah. And that was worth 4 points. So we'll go through and do it the way I think that you were trying to do it in a second, Noah. Let me, I'm going to pause this for a second. So Noah was talking about trying to do this in a different way, right? And so we're going to go through, because you can definitely do part C a different way. We're going to do it anyway, because I want everybody to see it. So we had that h prime is equal to f of 2x. And we had that h of 0 is equal to 7. So if we're trying to figure out the values of each of these things, we should be able to say, well, if h prime is f of 2x, then h prime of 0 ought to be the same as f of 0, which is, I don't remember, I don't negative 4, it looks like. And that h double prime of 0, well, h double prime ought to be the derivative of this, which ought to be 2 f prime of 0 to f prime of 2x. And so what was f prime of 0? 2. So that should be 4. And then h triple prime of 0 ought to be the derivative of this, which ought to, h, we'll say h double prime is 2 f prime of 2x. So h triple prime ought to be 4 f prime of, f double prime of 2x. And so this should be 4 f double prime of 0. And what was f double prime of 0? Negative 2/3. So times 4. So that's negative 8/3. And then you'll plug all those things in. So yeah, 7 minus 4x plus 4x squared over 2 factorial minus 8/3 x cubed and over 3 factorial. And that should have come out to be exactly the same thing as what we got the other way. What is that? 4/9, right? Yeah. So everybody see that you could do that one either way. It should come out the same. Either way, that part was worth 4 points. All good? All right, cool. And then we have this one, yes? How'd this one go? Better or worse? Part A is going pretty well so far. Wonderful. All right, so we are looking for the radius of convergence of our Taylor series here. And how are we going to find that radius of convergence? Ratio test seems like a good way to me. So we'll do the limit as n approaches infinity of the n plus first term. So -1 to the n plus 2, 2 to the n plus 1, x minus 1 to the n plus 1 over n plus 1. Put that in absolute values. Multiply that by the reciprocal of our original thing. So that's going to be a -1 to the n plus 1. It's going to be a 2 to the n. It's going to be an x minus 1 to the n. And it's going to be an n in the numerator. And then simplifying all of that stuff down and getting rid of all the -1 to the powers, because those are all just ones, leaves us with a 2 in the numerator, leaves us with an x minus 1 in the numerator, leaves us with an n in the numerator, and with an n plus 1 in the denominator. Everybody good with that? Which gives us a limit of, as n goes towards infinity, n over n plus 1 goes towards 1. So this is just now 2 times x minus 1. And to find the radius of convergence, we set this less than 1. And then we have to divide out that 2. So we end up with x minus 1, or the value of x minus 1 is less than 1/2. And our radius of convergence should be 1/2. Good? You mean you put it outside the absolute value and then divide it? As long as you still divide it, that's fine. And that was worth 3 points for that part. So 1 point if you set up the ratio, 1 point for getting the correct limit of the ratio, and 1 point for the correct radius of convergence. Good? Part B wants us to find the first 3 non-zero terms and the general term of the Taylor series for f prime about x equals 1. Well, this is already about x equals 1, so that's fine. This is f. We just need to take the derivative of it, of our first 3 non-zero terms, right? So what are our terms of f? Should probably write those up. F of x should be, what do we get when n is 0? I'm sorry, when n is 1. Is it 2 times x minus 1? Yeah. 1, yeah, 2 times x minus 1. Okay. So 2 times x minus 1. What's the next one? Minus 2 times x minus 1 squared. And the next one? Eight thirds times x minus 1. That's just for x, f of x you're talking about, right? Okay. And then your general term we already had. I'm not going to rewrite that one out. Okay. So then what is f prime? Should be what? First one is 2. Second one should be minus 4 times x minus 1. Next one should be plus 8 times x minus 1 squared. And then our general term, the -1 to the n plus 1, 2 to the n, and the over n will all stay. This n will come out to the front, which will cancel with the n in the denominator. And we'll just have -1 to the n plus 1, 2 to the n, x minus 1 to the n minus 1. Good? Nope. Doesn't matter. We're good either way. Yep. And that was worth 2 points. Let's see. No, sorry, 3 points. 2 points for having the first 3 non-zero terms and 1 point for the general term. Good? Yeah. Right. And then let's see here. Part C, what was it asking? Taylor series for f prime about x equals 1 is geometric. Find the function f prime to which the series converges, and then use that function to determine f. Okay. So if we're looking at this, what is the common ratio between the terms here? I've missed an n on that, didn't I? To the n. So our common ratio is 2 times x minus 1, right? And so if we're going to figure out what our function is, we just need to, since it's a geometric series, put it into A. Oh, yes, negative 2x minus 1. It is alternating. That is true. So negative 2 times x minus 1. So we're going to put it into our A over 1 minus r. A is 2. And then 1 minus negative 2 times x minus 1 should be the function for f prime. And then we can simplify that down a little bit. Yeah, right, Jared? Okay. First term? Yep. Yeah, first term is 2, so that's all right. So we got 2 over, what does that become? It's really just a plus 1 plus 2x minus 2. So what is that? 2 over 2x minus 1? Yep. Everybody good with that? And then f prime of x is this. And then how do we find f? We just need to integrate, right? So f of x ought to be the integral of 2 over 2x minus 1. And what does that give us if we integrate 2 over 2x minus 1? U is 2x minus 1, du is 2 dx, so this is just natural log of u. So it should be natural log absolute value 2x minus 1. And we're doing an indefinite integral there, so we have plus a c. And then what do we know about our original function? What? What do we know about f of 1? What does f of 1 need to be? F of 1 needs to equal, no. What does f of 1 need to be? Right, this should be f of 1 plus our, I mean, this is our Taylor polynomial here, right? So it should be 0, right? Because there's no constant term there. So f of 1 needs to be 0. This is f of x. And so if we plug in 1, that gives us natural log of 1, which is 0, plus our constant needs to be 0. So our constant is 0. So f of x is just the natural log of the absolute value of 2x minus 1. And that was worth 3 points. 1 point for f prime, 1 point for the correct antiderivative, 1 point for the final answer. And yeah, yep. We answered everything, should be good. Right, 0 plus that 2 times x. Yep, exactly. Yep. Everyone good with those two? We're feeling a little better about the series for responses now that we've done some closer to the test time? Okay, cool. Oh, I put a thing in Google Classroom. I also sent a remind message, but we will be having a review session on Sunday from noon to 2. I think I told you guys that yesterday anyway. Maybe I did, I think. So noon to 2, regular Zoom login for that. Yeah, noon to 2 on Sunday. So yes, you did. I don't know if I told the people in the Zoom. I did. Okay, good enough. For sure. And in addition to that, I think that it's good if you review the not AB, this is BC, the BC review session 1 and review session 2. I posted links in Google Classrooms, and I also posted the link to the third one. The first and second one, though, are just a general rundown of how to do everything in the class. So 3 hours well spent probably watching those. So fast forwarding through if you think it's easy partway through, but you know, find things that you're not so great with. All right, what did I say? We're gonna do a couple area volume ones, I think. That we said we do afterwards. I didn't give you any specific ones to do that, right? All right, you'll have to remind me which ones we've already done. We've only done the first two. Oh, there it is. Area and volume, FRQs, BC only. There we go. That's what I wanted. All right, so we did 1, we did 2. We've not done 3, 4. Let's, I guess we'll just start with 3. 3's got some just BC only stuff in it. It's not all BC only, but you all see that at home now?
Yes.
Great. All right, I'll give you guys 15 minutes to work through this one. This is a non-calculator one. Shouldn't be too bad. Ready, go. Part A, find the area. First off, what we need to do, we need to integrate x e to the x squared from 0 to 1. How'd you integrate that? Doing a u sub. U equals x squared. Du is 2x. So put in a 2 and a 1/2. You end up with 1/2 the integral of e to the u du. And then since u is x squared, 0 squared is still 0. And 1 squared is still 1. So those stay the same. And so we just end up with 1/2 of e minus 1. And then you need to find the area of the bottom piece. If it were me, I would just make it a triangle, 1/2 the base times the height, and just make it positive, even though it's below the x-axis. So the scale here is really nice. This is 1 for our base, and then our height, since this is 2x, right? Then really this should be 2. So 1/2 of 1 times 2. Even though it doesn't really look like it in the picture, gives us 1. So we have 1/2 e minus 1/2 plus 1, or 1/2 e plus 1/2. That's an e. Good? Any issues with the area there? Those were 3 points. 1 for having the integral, 1 for having the right antiderivative, 1 for the answer. And if you did it as x e to the x squared minus negative 2x, that's also fine. You did that just doing like, one function minus the other one, since it's the area between the two curves. Either way is good. Everyone's good with that? All right, part B. What did part B ask? We're going to revolve this region around the line y equals -2. So that should be washers. Right, so this should be pi times an integral from 0 to 1 of our outer radius. Our outer radius is the distance from y equals -2 to x e to the x squared. So that'd be 2 plus x e to the x squared. And that's our radius, so squared, minus our inner radius squared. Our inner radius is 2 plus -2x, so 2 minus 2x. And we'll square that. Dx, I assume that they didn't ask us to evaluate it. No. So that was worth 3 points. 2 points for having this in the integrand, 1 point for making sure you had the pi in the right interval, 0 to 1. Good or no? Everyone good with that? I hope not. Good thing we did this. All right, part C asks us to write but not necessarily evaluate an expression involving one or more integrals to give the perimeter of R. Well, that'd be this length plus this length plus this length. And we should be able to find the length of this diagonal line pretty easily. That goes from the point 0, 0 to the point 1, negative 2. So that's 1. That's 2. And that's 1. And so what is the hypotenuse of that? Root 5. So that's one piece of it. Plus, next piece, it's easy. This piece is 2. Even though their picture is really, yeah, their picture is awful. This piece right here is 2. Then we need this piece, which ought to be, it ought to be 1 e to the 1 squared, right? Or just e. So root 5 plus 2 plus e plus, now we have the only integral we actually have to do, an integral from 0 to 1 of the square root of 1 plus f prime. And so f of x was x e to the x squared. So what is f prime of x? Is it? That doesn't sound right, but could be. X times the derivative of e to the x squared, which is e to the x squared times 2x, plus e to the x squared. So that looks to me like that's 2x squared e to the x squared plus e to the x squared. I did the product rule. X, and then times the derivative of e to the x squared, which is e to the x squared times 2x. And then plus e to the x squared times the derivative of x, which is 1. So that should be, you need to write 2x squared plus 1 times e to the x squared squared dx. Which, that was worth 3 points. 1 point if you had the correct derivative, 1 point if you had this integral, and then 1 point for all of the other little easy linear pieces. Good or not? How do we feel about that one? You've made all the mistakes now so that you won't make them on Monday? Yeah. Perfect.
Wait,
you good?
Wait, could you explain? Like, I don't remember seeing that like equation. Like,
seeing what equation? The arc length formula?
Yeah, the arc length formula.
You must have taken a nap during class one day. The arc length of something is the integral from a to b of the square root of 1 plus f prime of x squared dx. That's the arc length formula for rectangular coordinates. And then in terms of polar or parametric, it's just, or even with vectors, it's just the Pythagorean theorem. So it's just an integral from a to b of the square root of dx dt squared plus dy dt squared, or dx d theta squared plus dy d theta squared.
Okay, I see.
Yep.
Thank you.
And that's, I mean, this one also just comes straight from the Pythagorean theorem, from the distance formula as well. It's taking tiny, tiny little line segment pieces and then summing together an infinite number of those line segments to find the actual value. Good now? Everybody good now? Product rule. So x, and then derivative of e to the x squared, which is e to the x squared times 2x. And then for the product rule plus this function, e to the x squared times the derivative of x. Everyone good? You good then? Yeah. Derek good. Jenna good. Noah good. Zoom good?
Good Zoom.
Good Zoom. Okay. What do we think? This one? It doesn't look like I'll have time for you guys to do this one, but we won't have time to go through this one till next time. So we'll do this one. I intend to just give you what did I say is on the quiz tomorrow? Rate? Did I? There'll still be quizzes. This week will just be a rate FRQ. That's fine. And there will just be one because I'd like to have some time to go over some more stuff in class. So just one question on tomorrow's quiz on the rate FRQ. So this will be the first one we go over tomorrow, but I'll give you guys 15 minutes to work through it right now. Ready, go.